Hello students, welcome to today's lesson where we are going to continue with the temperature and thermometers. We are going to look at the differences or the relationship between Celsius scale and Kelvin scale, and they are related using the following relationship. That is, temperature in Kelvin is equals to temperature in degrees Celsius plus 273. We have another term that we call absolute zero temperature. This one is the lowest temperature on Kelvin scale in which the energy of the particles of a material is zero. It has a value of 0 Kelvin, and this is at negative 273 degrees Celsius. How to convert the following? That is, you want to convert Celsius to Kelvin. We start with an example. Remember, we have given a relationship here. So in our example, we are going to use the above relationship. So if you have degrees Celsius and you want to convert them into Kelvin scale, you just add 273. So we have our first example. You have negative 20 degrees Celsius. You add 273, you get 253 Kelvin. Then we have 0 degrees Celsius. You add 273, you get 273 Kelvin. Then you have 100. Again, you add 273, you get 373 Kelvin. You have negative 273 in our fourth example. You add 273, you get 0 Kelvin. And this is what we have called absolute zero temperature. Then we have the conversion from now Kelvin to Celsius scale. Now, when you rearrange this equation and start with theta, you'll find that theta, which is degrees in degrees Celsius, or the temperature in degrees Celsius, will be given by Kelvin minus 273. So we look at the first example. We have 0 Kelvin. You just need to subtract 273. You get negative 273 degrees Celsius. Then number 2, you have 167 Kelvin. You subtract 273, you get negative 106 degrees Celsius. Then you have 283 degrees Celsius. That is 283 Kelvin. You subtract 273, you get 10 degrees Celsius. Finally, we have our final example, that is 3450 Kelvin. You just need to subtract 273, you get 3177 degrees Celsius. From there, we have another example. We have that an uncalibrated mercury thermometer is attached to a centimeter scale which reads 14 centimeter in pure melting ice and 30 centimeter in steam. If it reads 10 centimeter in freezing mixture, what is the temperature of the freezing mixture? We first look at the equivalent. We have seen that at 0 degrees, this one is corresponding to 14 centimeter. Then 100 degrees Celsius is corresponding to 30 centimeters. So we can be able to get the difference. From 0 to 100, you have 100 degrees Celsius. Then from 30 to 14, you get 16 centimeters. So it implies 100 degrees Celsius corresponds to 16 centimeters. So what about 1 centimeter? You divide through by 16. And when you divide, you get that 1 centimeter is equivalent to 6.25 degrees Celsius. But now our question was the temperature at the freezing mixture, which is at 10 centimeter. So first of all, we get the difference. The 10 centimeter minus 14, you get negative 4. Then you multiply by the equivalent of 1 centimeter, which is 6.25 degrees Celsius. When you multiply, you get negative 25 degrees Celsius. We move to another example. A 40 thermometer reads 18 degrees Celsius at ice point and 80 degrees Celsius at steam point. Determine the correct temperature when it reads 16. Again, we look at the equivalence. 0 degrees is corresponding to 18 degrees Celsius. 100 degrees is corresponding to 80 degrees. So we can be able to get the difference. That is, from 0 to 100, you get 100 degrees. Then from 80 to 18, you get 62. So it implies 100 degrees Celsius is corresponding to 62 degrees, that is in the 40 thermometer. From there, we need to ask, what about 1 degree in the 40 thermometer? So you get 100 degrees Celsius, you divide by 62 to get 1.6 degrees Celsius. So 1 degree Celsius in 40 thermometer is equivalent to 1.6. So from there, we need to get now the correct temperature when that thermometer reads 60. We need to get the difference, 60 minus 18, that is the differences in temperature, then you multiply by 1.6. When you multiply, you get 67.2 degrees Celsius. That will be the correct reading. Then from there, we have another example. On a given thermometer, the temperature of a melting point of ice was marked as 20, while that of steam above boiling water was marked as at 100, and this was done at normal pressure. So calculate part A, the temperature in degrees Celsius when the reading of this thermometer is 40, and part B, the thermometer reading when the temperature is 40 degrees. We start with the first one. First of all, we always get the difference. We are getting 100 minus 20, you get 80. So it implies 80 degrees on this thermometer is equivalent to 100. What about 1 degree? You divide by 80, you get that 1 degree is equivalent to 1.25 degrees Celsius. From there, we need to get the reading when the thermometer reads 40. So we get the difference in temperature, that is 20. 40 minus 20, you get 20. After getting the difference, you multiply by 1.25, you get that it is 25 degrees Celsius. That will be the reading, or that will be the temperature when the reading is 40. We come to the second part, the thermometer reading when the temperature is 40 degrees. We proceed as what we've done. We have that 100 is equivalent to 80. What about 40? When you cross multiply, you get that 40 will be equivalent to 32 degrees Celsius. So 40 degrees is equivalent to 32 degrees Celsius. But remember, now we want the thermometer reading. So we have to add the temperature at freezing or at melting ice. So you add 20. So it implies that the reading will be 52 degrees Celsius. From there, we move to clinical thermometer. This one is a special type of thermometer, and it is used for measuring human body temperature. Therefore, its temperature ranges from 35 degrees to 43 degrees because that is where we have the normal temperature of a human being. We have the figure here. In this figure, we have constriction, and as you can see, it has the scale from 35 to 43. So what is the purpose of this constriction? As you can see, this is a curve. So when you hit, or when this bulb is in contact with the body of human being, the bulb or thermometric liquid will expand and it will rise through our capillary bore. So this one prevents that mercury or that liquid from turning back to the bulb. So you can be able to get the reading even when you remove your thermometer from the contact of the human body. So the constriction will break the mercury thread for the temperature reading to be taken. After the thermometer has been read, the mercury is returned to the bulb by lightly shaking the thermometer. Now when you want to clean this or when you want to sterilize, we use the mentholated spirit. We cannot use boiling water to sterilize because the temperature of boiling water is very high. It is at 100 degrees Celsius, and therefore when you use it to sterilize, you are going to destroy your thermometer. Remember, the range goes up to 43 degrees Celsius. From there, we have the laser thermometer. As you have seen in the diagram, we have, this is what we call the laser or what we call infrared thermometer. Again, this one is used to measure the temperature of moving objects. So what it measures is that it is used when we don't need to make a contact. That is why we are calling it infrared or laser, because it operates by the use of thermal radiation. When the body emits thermal radiation, this thermometer is able to detect, and you're able to get the reading of the body temperature. Now this one is used to measure in accessible areas, or when you have moving objects, or objects that are very hot, or rotating objects, or when you want to get the temperature that is rapidly changing. It is also useful when you want a fast response. For example, this instrument is being used currently to get the temperature of human being because of this pandemic, that is COVID-19, because this is where we want fast response. We want to know the temperature of people who are entering a given area, so we use RISA, or what we call infrared thermometer. From there we move to our last type of thermometer, that is 6 maximum and minimum thermometer. And as you have seen in this diagram, it has two bulbs. This is R and this is S. In R, it is filled with alcohol. Then we have index X. At the lower part we have mercury. In S, we have a space that we are calling the space of expansion. Again, it is having alcohol, and it has index Y. If you look at the scale on this maximum part, it is starting from -20 moving to 50, which is maximum. At the minimum part we have, it is starting at 50 degrees Celsius and it is moving to -20, which is minimum. So how does it operate? We start when the temperature rises. The alcohol in bulb R, this one, expands. As it expands, it pushes mercury up the right rib, this part. It will push this one, and this mercury will push the index Y, and this index Y will be pushed upward. As you can see, as it moves upward, it is moving towards the maximum values of temperature. So for you to get now the maximum temperature, you read the lower end of this index, this part. So if we say that it has moved up to this position, you read what is the lower part, or what is corresponding to the lower part of your index. That way, you are able to get the maximum temperature reached during a specific period of time. Then when the temperature falls, this alcohol will contract. It will contract, and as it contracts, it pulls mercury back, rising on the left lip, this part. So as it rises, it pushes index X upward. This one, remember, this one has contracted, so this one will be pushed upward. And as you can see in our scale, it is starting from 52 towards the minimum. So as it is pushed, it will move upward. And for you to get the minimum temperature, again you read at the value that is corresponding to the lower end of index X. So that way you are able to get the maximum and the minimum value of your area. But remember, as this one was moving towards the left lip, it left index Y on the initial position. So for you to use the thermometer again, you need to reset. And this is done by using a magnet so that it can return the still indices to the original position. From there we have the assignments. If you look at the first one, it is calculation. The second one is calculation. So make sure that you are able to comprehend this video or the notes, so that now when it comes to assignment, you can be able to attempt and get the correct answers. So work hard, practice, and ensure that you are able to recall everything. Physics is easier. So thank you, and let us meet in our next lesson.